Hello, welcome back. My name is Courtney Snyder. This week we're going to be talking about geometric figures. Before we begin, I want to tell you guys a little joke. What did the triangle say when he was driving through the traffic circle? This is pointless. All right, so we're going to begin with this slideshow that I created to help walk you guys through how to do some of these problems that we're going to be talking about. All right, so this is our first problem. We have two parallel lines, as you can see right here, one up top with angles 1 through 5, and then one that we already know the measure of this angle, it's 63. Now we have another parallel line that has our measures, our angle measures 6 through 12 that we are wanting to find out, and we already know the one of this one over here that is 61, and we need to find the others. Now you see these two lines that go through our parallel lines. These are called traversal lines. They are lines that cross over or intersect with our parallel lines, which are the lines that never touch. So I know when you look at this, you're wondering, where do I begin? How do I know which angle to find first? And we're going to walk it through just so that you guys can see, and it is super easy once you get the hang of it. So we're going to begin with angle number 7. We have a triangle right here in the middle, and we know the sum of all three angles in a triangle is equal to 180 degrees. So we have two of our angles already. So what we need to do is we need to put that into an equation of 63 degrees plus 61 degrees plus x, which is angle 7, equal to 180. And when we equal those to each other, or when we add these two together and subtract them from 180, after we do that math, what we get is 56 degrees. Now, from here, we can go one of two ways. And I'm going to show you both, or I'm going to tell you both and show you one now, and we'll go over another one here in just a little bit. So this first one I'm going to show you is we're going to be looking to find the angle for angle number 8. So angle 7 is 56 degrees. And we know that a straight line is equal to 180 degrees. So if we take a triangle, unfold it, and lay the lines completely flat, it's going to equal 180 degrees as well. So we're going to do 56 plus x, which is for the angle that we're wanting to find. And we're going to do subtract 50 from 180, and we'll get 124 degrees. Now that is what angle 8 is equal to, is 124 degrees. Now we're going to move on to angles 11 and 12, but there are two ways that we can do it. So angle 12, you see, is a vertical of angle 7. So they are going to be congruent, which means that they're exactly the same, and they're going to equal the exact same. Same with angle number 8 and angle 11. They're verticals, so they're going to be exactly the same. But we can also work it out the same way that we did angle 7 and angle 8 when we found it. We can set them to 180. So angle 7 and angle 11 is on a straight line right here that's equal to 180 degrees. We could subtract 56 again, and angle 11 will be angle 11 will be 124, and then angle 8 and angle 12, setting that to 180 degrees, subtracting 124, we're going to get 56. And see here we have angle 12 is congruent. Now this is the symbol for congruent to angle 7. So angle 12 is 56 as well. And the same with angle 11. It's congruent to angle 8. So angle 11 is 124 degrees. And like I said, we can figure those out both ways. We can see that they're verticals and that they're congruent, or we can set it to a straight line 180 degrees and figure it out that way. So now we are going to move on to angle number 9. And like I said before, angle with angle 7 and 12, they are congruent because they're vertical and they have the same angle measurement. So pretty much what they're saying when they say congruent is if I took a line and I drew it at the bottom of this triangle right here, when I flip this triangle onto this one, it will be the exact same size. Congruent pretty much means all its angles and side measurements are exactly the same. So they will fit exactly the same. So we're going to do number 9, or angle number 9. Now we already know that this angle right here is 61, and angle 9 is its vertical. So we're just going to say angle 9 is congruent to angle 61 degrees. So angle 9 is 61 degrees. And now we can figure this out another way by setting this line to 180 and figuring out 6 and then figuring it out 9. But knowing that they're verticals and that our verticals are congruent makes it a little bit simpler and less math for us to solve. So now we are going to figure out angle 6 and 10 now. We are going to start with angle 6. And what we are doing here is we are setting it 100 degrees. And we are going to subtract 61 from x. And that will give us 119 degrees. Now, 119 degrees is what we have for angle 6. And again, 10 is our vertical. So angle 10 is congruent to angle 6. So angle 10 is also 119 degrees. Now we are going to move up here to angle number 2. As you can see, this one has a lot more angles to it than these were that we were working down here. This one just had 4 angles. But we do it the exact same. We have this angle right here, and we know that it's 63 degrees. And so this angle number 2, which is vertical from it, is going to be 63 degrees as well. Now we are going to work on to angle 3. Because we know that angle 9 and this angle are the same, they're congruent. Angle 9 is also congruent to angle 3, because if we took this angle right here and just moved the line up, it's going to be exactly where angle 4 is. So we know angle 3 and angle 4 both are going to be 61 degrees. So angle 1 is congruent to angle 12, because the same with angle number 9. If we moved it all the way up to here, it would be the same as angle 5. So angle 1 and 5 will be 56 degrees. As you can see here, angle 4 is congruent to angle 3. It is a vertical of it. It's on the opposite line. And the same with angle 5. It's a congruent to angle 1, so number 5 is 56 degrees as well. Now we are going to move on to this triangle. And inside it, we see that we have a diamond shape, rhombus. So again, we are wanting to find all these angles. Now the difference between this one and the one we were working before is we're not finding just a triangle. Now we could draw a line from here to here and make 2 separate triangles, but that's not what we're wanting. We are wanting to find them set just like this, and it's pretty much the same that we did before. So what we're going to do is we're going to look at the bigger triangle right here. These 3 points right here. We're not going to worry about these angles right here inside just yet. We're going to do 74 degrees, 26 degrees, and angle 1. That's where we're going to start, is with angle 1. And again, we're going to add them all to 180. And we're going to subtract 74 from 180 and then 26 from that. And we're going to get 80 degrees. So angle 1 is 80 degrees. Now, we are going to move on to angle 4. So angle 4, this, again, the same with the verticals and the congruent. If I took this triangle with angle 8, 6, and 26 degrees, and laid it right on top of the triangle that had 74 degrees, angle 3, and angle 4. If I laid them right on top of each other, they would line up perfectly. Excuse me, sorry. They would line up perfectly because the sides measurements and the angle measurements are exactly the same. So 26 degrees is congruent to angle 4. So angle 4 is 26 degrees as well. Now, we're going to move on to angle 3, and we're going to do this one the same way we did the big triangle. We're going to do 74 and 26 minus 180. So angle 3 is 80 degrees as well, which makes 1 and 3 also congruent. They're congruent angles. Now we're going to move on to angle 6. Angle 6 is congruent with 74. See, again, if we lay the triangles on top of each other, they are going to line up perfectly. So angle 6, congruent, this symbol right here, congruent to 74. All right, now angle 1 and 5 are also congruent because, again, if we put a line right down this middle, flipped it over, it would be exactly the same. So angle 5 is congruent to angle 1, so that one is also 80 degrees. Now, angle 1 and angle 8, they are also congruent because if we move this triangle over here, it's going to be the same angle. We're subtracting 74, and we know that angle 6 now is 74 degrees. So we're subtracting 74 and 26 from 180, leaving us angle 8, which is 80 degrees. Now we are going to move on to angle 7. Now there's different ways that we can figure this out, but angle 7, the way I find easiest to do is 7 and 8 are right here on a straight line. If I put a point right here and a point right here, it would make a line segment, which has an ending and starting point. And it would make 180 degrees. So we're going to set these two to 180 degrees. We have angle 7 plus 80 equals 180 degrees. We're going to subtract 80 to both sides, and that gives us 100 degrees. It makes angle 7 100 degrees. Now we can do the same over here with angle 2 and 3, but we can see that angle 3 is 80 degrees because angle 3 and 8 are also congruent angles, because if you lay those triangles on top of each other, again, they're going to be exactly the same measurements. So angle 2 and 7 are congruent, and they will be both equal to 100 degrees. Now we have a concave polygon. Now, what makes this concave? That's a very simple thing to add. Concave is if I put my pencil down on this shape and drew a line from 3y over here in the corner all the way to the 3y down here at the point. And if at any point during that line that I drew, did it go outside the shape? If it went outside the shape, then it is concave, meaning it's caving in. Now, convex is another term, which same way to test it. If you put your pencil down anywhere on the shape and drew it from one point on the shape to another point on the shape, if it goes outside the shape at all, it's concave. And if it does not, it is convex, meaning it all points outwards. So what we're wanting to find here is the measurements of these angles. Now, we don't have a solid measurement. All of them have y. So we're going to need to figure out what y is. How do we do that? So we are given this equation, n minus 2 equals 180. N is equal to the number of sides that a shape has. This one has 1, 2, 3, 4, 5, 6, 7, and 8 sides. So n is equal to 8. So we're going to plug 8 in. 8 minus 2 times 180, that gives us 1,080. That is the total amount that all these angles are equal to. So now how do we figure it out from there? What we're going to do is we're going to take all of these angles and add them together. So we're going to have 3y plus 7y plus 7y plus 7y plus 3y plus 12y plus 12y plus 3y. Add them all together. That's going to give us 54y. We're going to divide both sides by 54, and that gives us y equals 20. And so we're going to plug y into each spot we see y. We're going to plug y in, and we're going to solve for y. So 3y would be 60 degrees. So everywhere you would see 3y, you would put in 60 degrees. So it would be 60 degrees in this corner, 60 degrees here, and 60 degrees at this bottom point. And then we're going to plug it into 7y, which equals 140. So all these top 3 points are equal to 140. And 12y is 20 is plugged into 12y, and that equals 240. Now we have the answers. How do we know they're correct? The easiest way to find out if your answer is correct is what we're going to do is we are going to take these numbers right here that we have, 60, 140, and 240, and everywhere you see 12y, you're going to put 240. Everywhere you see 7y, you're going to put 140. Everywhere you see 3y, you're going to put 60 degrees. We're going to take those numbers and we're going to add them all up, and they should all equal 1,080. And that is how you know that you have the correct answers for these angles. Now we moved on to interior, exterior, and central angles. So where are they located? What are they for? So again, we're going to use this same equation. This has 9 sides. N minus 2 equals 100 or times 180. N equaling 9 for this shape. It has 9 sides, so it's called a nonagon. And so the sum of all interior angles would be 1260. 9y, meaning the 9 angles inside, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 angles. And with the assumption that, well, my picture is not drawn to scale, but with the assumption that all the angles equal the same amount or have the same measurement, we are going to use 9 for 9 angles, and y being what we want to solve. That gives us y equals 140. Now to do your central angles, we're going to do n minus 2 times 180 divided by n. Again, here's our interior angles. They're equal to 140 because we're dividing 1260 by 9, giving us just y. Because we have the assumption that each angle just has a y there. So it'd be 1y plus 1y plus 1y plus 1y, equaling up to 9 y's, dividing it. So each interior angle is equal to 140 degrees. Now our central angles, we are doing 360 divided by 9, because that is how many sides there are to our shape. There are 9 sides to our shape, so we're going to divide 360, so a complete circle, which is equal to 360 degrees, we're dividing it by 9. So that gives us 40 degrees. So our central angles right here are 40 degrees, this angle right here. Now we're going to do our exterior angles. Now this exterior angle right here. Now, what we already know from previous problems we've worked is that a straight line is equal to 180 degrees. So we are going with the assumption that all the interior angles equal 140. We're going to assume this angle right here on the interior is 140, and we are wanting to know what this exterior angle is right here. This line just continued up out of this shape, and this is a whole nother line, adjacent line, coming to this point, which is also known as the vertex. So this angle right here is 140. So 140 minus 80, it gives us 40. So our exterior angle is 40 degrees. Now we are going to talk about tetrahedron, a tetrahedron. Now what is a tetrahedron? A tetrahedron is a shape that has 4 faces. So we can see right here, this is our tetrahedron. It has one face right here, this dotted line, one face, another face using this dotted line, and this one, and this bottom to our base. Our base is a triangular shape, and our base is also a face. So this is right here is a face. This right here is a face. This big triangle is a face, and then using this dotted line right here that runs across, and these 2 solid lines on the outside is a whole nother face. So there's 4 faces. So what we're wanting to do is we want to put this triangle, or this tetrahedron, inside this cube, but we don't want any of the faces of this tetrahedron to touch any of the faces of the cube. So how do we do that? Very simple. We're going to go ahead and slide it over. Now we have vertex E and vertex D having one of the edges of our shape. You see, only our edges are touching the face of this cube, and that is exactly what we want. We have edge ED touching the face of AEHD on the cube, and edge DG touching the face of GHDC. And that is exactly how you would make your tetrahedron fit inside of this, using the vertexes of the cube and the edges of your tetrahedron to go against the face without making the faces touch each other. Now, what are these shapes that we're going to go over? Let's see here. And again, this is a tetrahedron. See, this is a 3-dimensional shape of it. We cannot see the base to the triangle, but this outside right here is our base. And think of it as a pyramid coming up. So here's one face, here's 2 faces, here's 3 faces, and the bottom face is our 4th face. Tetrahedron is meaning 4, meaning there's 4 faces. Now an octahedron, that's a 8-faced shape. And what it is our base is made up out of a square. We have a square right here, and you can kind of see it in the middle. So basically, let's take 2 pyramids. One base here, and you've got your faces coming up, and then you have another base here, and your faces coming down. And we're just going to flip them on top of each other. So we have our pyramid coming up and our pyramid coming down. We have 4 faces. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 faces. We have 6 vertexes. 1, 2, 3, 4. This top point and this bottom point being 5 and 6. So those are our 8 vertexes. Now we have 12 edges. 1, 2, 3. This dotted line back here, that is the back of our shape that we can't see, is 4, 5, 6, 7, 8, 9, 10, 11, 12. An octahedron has 12 edges. Oh, and on the tetrahedron, we have 1, 2, 3, 4, 5 vertexes, and 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Now this one is an icosahedron. It has 20 faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 vertexes. And so you'll see when we count the faces, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So those are the shapes that we are going over. And I hope you guys enjoyed my PowerPoint. And thank you for letting me present it to you.